Question 1. It says 100 adults were asked how they keep fit. I'm going to draw a grid here, which is helpful. So we can either have gym, run, or cycle. And they're either male or female. So it says 45 of these adults are female. So if I do this grid like so, then we know that our totals here, we've got to end up with 45 females. So that means there'll be 55 males because there was 100 adults. So this one's ticked off. 30 of the 52 adults who go to the gym are female. So that says 52 here. We have to put this as a total as well. Then we know that this is 22. So that's something that we didn't have necessarily, but we've got now, as well as this. 35 adults run. Okay, so we're given that information. And it says 9 males cycle. So if 9 males cycle, then we've got a missing link here because 22 and 9 make 31, and so this would have to be 24, okay, to make the 55 here. And then the nice thing is here, we can find this one here because 24 and something make 35, so that's got to be 11, and then we can just read across here on these ones, 30 plus 11 is 41 and 4, and then read downwards, 4 and 9 is 13, which we can type in here, write in here, and then we can add these up and hope, cross our fingers, that 52, 35 and 13, you can use your calculator, 10 is 100. So that's how I would do it. So just tick each one off as you go, and it's quite difficult to go wrong. It says how many females run. Well, the answer here, if I put it on the answer part, would be 11 females run. Okay, so not a bad start to the paper. Question 2, I think a bit of a tricky question. So teachers to students, the ratio is 1 to 15. And then it says the number of male to female students this is, not teachers, is 7 to 5. But I think what we've got to do is play around with these ratios until these make sense to each other, i.e. we've got to try and make it so these parts for males and females add up to give us the number here. So we can change this ratio to 2 to 30 and then double it again to get 4 to 60. And then the nice thing about this is if we times this one by 5, we'll get 35. Times this one by 5, we'll get 25. And look what happens. 35 males, 25 females make 60 students. So if we want to work out what percentage of all the people on the trip are female students, now notice it says what percentage of all the people on the trip are female students. So all of the people. So we know that there are 60 students here because these correspond, but we want to take 25, the females, out of the total number of people on the trip, which would be 64. Okay, not 60. That would be the percentage of students that were female, but the teachers went on the trip as well. So it's 25 divided by 64, and as a decimal that gives me 0.3900625, and of course to change a decimal into a percentage we times by 100, so we'd get 39% to the nearest whole number. Okay. Question 3. In the space below, we've got to use ruler and compasses to construct the perpendicular bisector of the line AB. Well, believe it or not, I don't have a compass in the house, which is really annoying. That's why I kept this question till last. but I can explain by using the word S for sharp point and P for pencil. So S is sharp and P is where your pencil will be. So if you put your sharp point of your compass here, extend it so it's at least halfway over the line, and then you can draw a nice arc of a circle up here. You can do it all the way round if you want, it doesn't really matter. And then change over, keep your compass and pencil the same distance away from each other. So you put your sharp point here now, so that would be S1, the first position. This would be the second position, and do the same. And then don't forget, when you did it in the first position, this one would carry all the way round to here, wouldn't it? And this one here in the second position would go all the way down to here. And all you have to do is join this point and this point up with a ruler. So I'll try and draw a nice straight line if I can. Let's change the colour. So there would be my line, and that would be my perpendicular bisector, so it'd have to meet this at right angles and cut the line AB in half, i.e. bisect it. I'll just add in P here so you can see where the pencil should be. So they're your pencil lines, and these are the points where you put your sharp point of your compass. Question 4. We're given a quadratic graph. We've got to write down estimates for the roots here. So we've got to look carefully at the graph and estimate these. So I'm going to zoom in a little bit and let's see if we can see what we've got. So we've got 1, 2, well, this would be 3, so it would be 3.2, that's 3.4, 3.6, 3.84, so I'd say 3.23 or something like that. So I'd say this would be 3.2 thereabouts, and this one I'd have -1, there's -2, so -1.2 would be a good estimate for that one looking at the graph. Okay, so there's my two estimates for the roots. Now it asks for the coordinates of the turning point. Now this is not how you would do this, but if you just completed the square, you'd have x minus 1 all squared minus 1 minus 4, which should give you x minus 1 all squared minus 5. So the answer would be 1, 5. And if you look at one of the other questions on this paper, it actually asks you to do this algebraically. In this case, that's -5 there. In this case, you just have to look at the graph. Okay, it's a bit ambiguous. It doesn't actually tell you, so it should say maybe in part B, estimate the turning point. But anyway, I think that you're allowed just to look at the point on here, and you've got -1 here. So if you read down, then you can see that that is -5. Now some of you could argue, well, how do I know it's exactly -5? Well, you don't. You're just estimating it. And if you want to be sure, though, I think on a higher paper, if you've got these skills, then show them anyway. So you can actually just say, draw an arrow or something and say that using the graph, or back it up with some algebra as well. And the explanations behind how this works are in another question. And that question is question 19. So look at question 19, which has got, again, a partial explanation of how to do it. Question 5. The track has two straight sides, each of length 40. So we know that the length of the track is going to be 2 times the 40 plus 2 of these curved parts of the semicircle, so the semi-perimeter of the circle radius 27 doubled, or if we put these both together, then we'd end up with the whole circle, wouldn't we? So we can look at the circumference of a circle of radius 27 metres. So that would give us 80 plus the circumference of the circle is pi times the diameter, or 2 pi r, 2 times pi times r. So that's easy enough, so we can get to that one quite quickly. So we'll do 2 times pi times the radius, and that would give us 54 pi. Now I'm just going to put all of this into the calculator and get a nice decimal then. You don't have to write a decimal here, but I just think most of you would just want to do that. So 249.6460033 metres. So that's the length of the entire track. So now we've got to look at the diameter of Ian's bike wheel. That's the diameter now. So notice we were talking radius here. So this is quite tricky. You've got to pay good attention to this. So 590 millimetres is, well, 1,000 millimetres are a metre. So the diameter is 0.59 metres. We want to get the units the same. So we know then that the circumference of Ian's bike wheel would be pi, so pi times the diameter, pi times 0.59. So we'll do that, pi times 0.59. So we get as a decimal 1.853539666. I shouldn't really write equals here. I'll just put these in a bracket because it's an estimate, and that's in metres. So all we have to do is this number here divided by this number here. So, and so on, divided by, but for goodness sake, whatever you do, write down every single digit on the calculator display. So I'm going to do that now. So 249.6460033 divided by 1.853539666, and that gives me 134.6860862, but it's the number of complete revolutions. So 135, you'd be tempted, but actually Ian wouldn't have done that if he'd have gone round the track. He would have only done 134 complete revolutions, complete revs. Okay, so 134 would be my answer. Question 6. We've got the front elevation and a plan. So the plan is like looking down on the object from overhead. Imagine you're flying over the top of it, and you would see this situation here. So the only other elevation is to look at the side one, so we're looking at it from here. So my advice is I would look at this bit first. That's 1, 2, 3, 4. And how wide is it? Well, you can see here from the plan that it's 2. So if I do this diagram here, so I'll have 2, and then 1, 2, 3, 4. And the interesting thing that I've just noticed, so I could have got this wrong if I wasn't paying attention, the arrow is facing this way, so it wants it from the side this way. So you'll have to step it up, so each time. So 1, and then 1, and then you've got your 2 here. So I would draw my finished diagram like so. Okay, so be careful, you can lose marks easily, as I nearly did there. Question 7. The distance from the Earth to the Sun is 1.496 times 10 to the 11 metres, and the speed of light is 3 times 10 to the 8 metres per second. Now we know speed is distance over time, so we want to show that correct to 3 significant figures, light will take roughly 0.139 hours to travel from the Sun to the Earth. So we know this distance here is in metres and the time is in seconds, so metres per second, and we want to see that light will take 0.139 hours. Okay, so we've got to do a little bit of a conversion. So let's rearrange this formula. So if we have S equals D divided by T, if we times both sides by T, some of you use formula triangles. I'm not a great fan of those, but if you like them, then that's good. And then I want to get S on and T on its own, so I'll divide both sides by S. So T will be D over S. So let's try and see what that gives us. So the distance will be 1.496 times 10 to the 11, and that's in metres, so put the units there to help you. And then the speed is 3 times 10 to the 8 metres per second. So why does that give us a time, which happens to be in seconds? Well, if you look at these units here, if you've got metres divided by metres per second, that's the same as metres times seconds over metres, and the metres cancel and you're left with seconds. So you can check that the dimensions here, I'll write this word down, it's quite important, dimensions will always give you a clue as to what's going on. So let's do that calculation first. Don't forget we want this in hours, so we've got it in seconds, so we've got to do some conversion later. So it looks as though we're going to get 498.6 recurring seconds, but we want to convert that to hours. So how many seconds in a minute? 60. So if we divide that by 60, that will get us to minutes. And how many minutes in an hour? 60. So if we divide that by 60 again, we'll get to hours. So when divided by 60 is like dividing by 60 times 60. So just make this clear, because it's like having your value divided by 60 and then divided by 60 again. So they go on the denominator here. So it's like dividing by 60 squared. So if we do 498.6 recurring, you can do a bar or a dot, it doesn't matter, over 60 squared. On the calculator, I get, let's have a look, 498.6 recurring. Just do lots of 60s on the calculator, it'll be fine. Divided by 3,600. If you do this, then whatever you do, put a bracket here, if you were to do it this way, if you were to do it like that. Because if you didn't put a bracket, then you would just have this number, you would have divided it by the first 60, but if you'd have left this bracket out, it would have then times the answer by 60, and you'd end up with 498.6 recurring, because you'd have divided by 60 and then times by 60. So the brackets are absolutely crucial depending on which way you do it. So my calculator gives me 0.13851 recurring. So to 3 significant figures, I would have 0.13, and luckily hours, 0.139 hours, and that's what we've got here. So I think that first part's a bit tricky, well it was for me anyway. The next part says, Danish says that when this situation occurs, 1.496 times 10 to the 11 times 6.68 times 10 to the 9 happens under multiplication, that you'd get 9.99 times 10 to the 99. And we've got to say, is that correct or not? Well, to be honest with you, if you're thinking that we times these powers together when we're multiplying, if we took 10 to the 11 and times it by 10 to the 9, surely you remember that that's going to be 10 to the power of 20, not 10 to the power of 99. That would be 10 to the power 11 to the power 9, or 10 to the power 9 all to the power 11. Then you'd multiply. So you can go through the motions on this and do this on your calculator. So 1.496 times 6.68, although that gives us a rough 9.99, it's actually 328 on the calculator. We'd have 10 to the power of 20 though. So really, if you wanted to say that it was a googol, then you could almost say that if that was 99, then that's nearly another 10, and so you'd have 10 to the 1 times 10 to the 99, and then if you were, then you'd have to kind of like add then. So really, by the wrong method, you'd have to use the correct method to then prove this was correct. So it doesn't make any sense whatsoever. So basically, you'd have a 20 here, not a 99, and it's only 1 mark. So be careful with these kind of questions. You really must try and show all the types of working that you can, because you can easily lose an odd mark here and there. Question 8. Find an equation of the straight line with gradient 3 that passes through point A. Well, if you had a gradient of 3, that means for every 1 you go along, you'd have to go up by 3 times as much. And that wouldn't be very good to do that in this particular case. So why not go back 1 and down 3? And then you can draw your straight line. So what about the equation then? Well, we know that the gradient is 3, so it's definitely in the 3 times table, y equals 3 times x, no matter what x is. But what's the intercept? Well, if we look carefully here, the intercept here is at -1. And we can verify that by just going back 1 on the x, which means we'd have to go down by 3 times as much. And there we are. We get to -1 on the y-axis. So that would be my equation. Question 9. Natalia pays £13,995 and Lauren pays £14,495 for a car. The rate of depreciation for Natalia's car is 12%. So if you're losing 12%, then the multiplier would be 100%, which is 1.00, or as many zeros as you want, and you take 12% off, which is 0.12 as a decimal, and you'd be left with a multiplier of 0.88. So for 1 year, that's how much you'd be left with, and then over the second year, you'd have to do that again, and then the third year again. But the quick way round is just to start with the principal sum, 13,995, and times by 0.88 3 times in a row, so to the power 3. And then likewise, this would be 13% depreciation, so 87% of its value left. So we just have to work these on the calculator and see what we get. So here's my figures here for the ending amounts. I'm going to convert them into pounds. So £9,537.20 to the nearest penny. And here we'd have £9,545 to the nearest penny. So work out whose car will have the greater value at the end of 3 years. Well, it would be Lauren's car. Okay, and is there any more to this question? Let's have a look. The rate of depreciation assumed for Natalia's car was too low. How does this affect the value of her car at the end of 3 years? Well, what it would mean is if the rate of depreciation was too low, then what it would have to say is that the rate of depreciation would have to be more, say 12.2% or 12.5 or 15 or something greater than 12. So it's a bit of a tricky question, because if her rate of depreciation is at the moment 12, but that is deemed too low, then the rate of depreciation has to be more. So that means it's going to be worth less. So I will say it will not be worth as much. So again, a tricky question with the words, the wording of it, so just be careful. Question 10. The scatter graph shows information about 10 adult snakes of the same type. It shows the length and weight of each snake. An adult snake of this type has a weight of 740 grams. So we're going 620, 640, 60, 80 and so on. So 740s here. So we're going to have to draw our line of best fit first. So I'll give this a try. And I get something like that. So as long as it roughly goes through all the points, I guess looking at it I could probably move this slightly closer this way. Okay, so let's read along from 740, which you must do with a ruler in your exam, and then read down here, and I get 75, 76, 77 centimetres. Okay, then the next part says Stephen wants to estimate the weight of an adult snake of length 110 centimetres. He says he will draw a line of best fit and read off the weight at 110. Explain what is wrong with his method. Well, what's wrong with this? Well, I don't know if you heard this word before. Extrapolate. Because 110 is outside the range of the data, because it only goes up to 100, you're having to make too many assumptions here. You could have altered the line of best fit to maybe given it a go, but when you're below the data or above the data, you can only interpolate, so that's between, interpolate on the data that you've got. So in this case, I would say 110 centimetres is outside of the range of data, so it would be unreliable. Okay. Question 11. We've got 47,805,000 and we want to write that in standard form. So how many powers of 10 will we have? Well, we would have 1, 2, 3, 4, 5, 6, 7 powers of 10. So we could write that as 4.7805 times 10 and again and again and again by 10 7 times. So we can put that to the test just to clarify. So if we started with that number and we times it by 10 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, we would end up with where we started from. So that would be the answer to question 11. Question 12, we have x squared minus 121, and if we wanted to factorise that, we could actually use the difference of two squares, because a squared minus b squared is always a plus b times a minus b. And if you don't know that from school, then, well, at least you've seen it now. And this is always going to give you a squared. This will always give you minus b squared. This will give you minus ab, but this will give you positive ab, so they always cancel. So it's very useful to know this one. So if you did x by x, that's x squared. 11 by minus 11 is minus 121, and then this would give 11x, but this would give minus 11x, so that goes. So the factorised form would be, and I'll write that in a different colour, the factorised form would be x plus 11 times x minus 11. You could also write x minus 11 times x plus 11. The order of the multiplication doesn't matter in this case at all. Question 13. The table shows some information about the weights in kilograms of some boxes, and Yusuf uses this information to draw the box plot below. We've got to write down two things wrong with the box plot. Well, the minimum value seems to be at 12, so that's fine. The lower quartile at 20. But here we go. The median should read 30. So the median point should be at 32, not 30 in the box plot. And then what else have we got here? The upper quartile, yep, that's at 40. Now the range. Now, what range do we mean here? So it doesn't say anything about the interquartile range, it just says about the range. So in this case, the range by the diagram seems to say 55, but the range is between the highest and lowest, so the range is actually on the diagram, the box plot, and the range is 55 minus 12, which is 43, which is not what you've been told to give as the range. So not an easy question, not for me anyway. So if this was 12 and the range had to be 55, then Yusuf would have to plot at 67, because then 67 minus 12 would be 55. So my last point would be maximum point should be at 67, not 55 as plotted. Okay, so just be careful with those types of questions, because we've got to assume that this information here is correct, and we've got to write down two things wrong with this box plot. We're not questioning this data here, we're questioning how it's been arrived at in the diagram. Question 14. Solve the simultaneous equations given. Well, the first one here, 4x plus 6y equals 5, we'll call that equation A. And the next one, 7x plus 5y equals minus 10.5, and I'd rather call that minus 21 over 2, if that's okay, and I'll call that B. So I think the first thing I'm going to do is I'm going to multiply B by 2 to get rid of this awkward denominator here. So that will give me 14x plus 10y equals negative 21, and I can call that equation C. So I'm going to really look at A and C, and I'm going to try and get rid of the coefficients of x, i.e. make the x values disappear by getting them the same and then taking the equations away from each other, or adding the negative of one of the equations. You've probably got your own ways of doing these simultaneous equations anyway. So let's have a look. I think I'll try and look at the lowest common multiple of 4 and 14. If in danger, you can just times equation A by 14 and equation C by 4. But because 14 and 4 are both even, you've got to realise that you could times the top one by 7 to get 28x, and the bottom one by 2 to also get 28x. So I'm going to do that. I'm going to do equation A times 7 and equation C times 2, but you could do 14 and 4, it doesn't really matter. So Equation a by 7 is 28x plus 42y equals 35. And equation c by 2 gives 28x plus 20y equals minus 42. You don't have to label these, I'm just doing this so you can follow what I'm doing. Some of you can realise here that you can either do d take away e or e take away d. What you can do, however, is just times one of them by negative 1 all the way through, and then you can just add them. So I'm going to do d plus e prime. I've called it e prime because I've changed it. I've times both sides by negative 1. And then look what happens. These values here will cancel out when you add the equations together. So I generally like adding equations all the time. It saves doing things like 42 minus 20y, and you can sometimes make a mistake. So here I'll get 22y is 77. So that means y is 7 times 11 over 2 times 11, which is 7 over 2, or 3.5. That's absolutely fine. You could have written 77 over 22. That would be probably okay as well. It doesn't ask you to give your answers in the most simple form. Now when you get y is 7 over 2, you've got a few choices. Choice number 1 is that you can just repeat the process. So if you had 4x plus 6y equals 5, equation A, and we use this one here, 14x plus 10y equals minus 21, equation C, then you could times the top one by 10, the bottom one by 6, or you could times the top one by 5 and the bottom one by 3. So I'm going to do that. So A times 5 and C, the bottom one, by 3. So the top one by 5 is 20x plus 30y equals 25. I'll call that D. And then C by 3, that will be 42x plus 30y equals minus 63. And then you can see that these coefficients are the same. So if you change the signs of one of them, I'm just going to do the top one, change the sign of that one, times both sides by negative 1, which is fine. And then I can do E plus D prime again. And I'll have 22x equals negative 88. So that would give me x is minus 8 times 11 over 2 times 11. So that just gives me minus 8 over 2, which you know is minus 4. The alternative is, once you had your 7 over 2, you could just put that into either A or B. I'd probably steer clear of B because it's got this horrible fraction in it. So if I sub y is 7 over 2 in A, then that would give me 4x plus 6 lots of 7 over 2 equals 5. This 2 and this 6 would cancel to give a 3, and 3 sevens are 21. So 4x plus 21 is 5, which will then give you, down here, 4x would be minus 16, so x would be minus 16 over 4, which again is minus 4. So there are plenty of ways of doing these kind of questions. I have got some playlists on simultaneous equations, so if you want to see the way I do them the quickest, then have a look at that playlist. Okay? Question 15. Prove algebraically that the difference between the squares of any two consecutive integers is always an odd number. Well, let's take an integer n, and then the next one after it, the next consecutive integer, will be n plus 1. So let's square these two numbers. So we'll have n squared here, and then n plus 1 all squared here. Now that's just n squared, but this is n squared plus 2n plus 1. don't forget when you're timesing n plus 1 by itself, you'll have an n squared of 1, but you'll also have an n here and an n here, which give you the 2n here. So if we want to find the difference between them, this is the bigger number, this is the smaller number, so I'm going to do the bigger one, take away the smaller one. It doesn't really matter, but let's do a nice little subtraction sum here. Well, you can see here that you're just going to be left with 2n plus 1. Now, why is that always an odd number? Well, 2 times anything is going to be even, and if I take an even number and add 1, then that's going to be odd. So that should be enough for this question. And I thought I'd just put my little explanation in here, which is, I guess, what you should do to get all of the marks. Question 16. Well, for this one we've got to describe fully the single transformation. So it's an enlargement, that's for sure, but for an enlargement we've got to give the scale factor and the centre of that enlargement. So bear with me while I try and probably make a mess of this. So you've really got to put a line through corresponding points here on the smaller and the larger of the triangles. So there's the first one. I'll change the colour of the second one if I can. So this is the other vertex here. So let's try not to move this around too much, or it's going to become a bit difficult. So there's the other one. So they're corresponding to each other. And then lastly, I'll do this one in this colour if I can. We'll have this situation here, so I'm going to just join those up as best I can. And of course you'll have a sharp pencil in the exam, okay? So without making a mess of this, can you see that would be my centre of enlargement? So my centre of enlargement would be at 4 along, 6 up. But by what scale factor? Well, that's okay, because all I've got to look at is, for example, this was 2 units, and here the corresponding one between a blue and a red is 4. So we've got to see which way around the transformation is. So m has got to turn into n. So m here we can tell is a scale factor of 2 to get to something like this. But if we look, as we're going from here, we're literally turning the triangle from its orientation upwards to being flipped. So it's going to go through this focal point here, or the centre of enlargement, and it's going to be therefore negative. So we know that that was 2 and that was 4, so we know we could say times 2, but I'm afraid that would be wrong. So the scale factor is actually times negative 2, okay? So you've got to be careful with that. And we've already said, and we can just say the word enlargement again, even though we've already stated it here. So just be very careful with those types of questions. I'm sure there are loads of videos on how to do enlargements, but that's how I would do it. I'd look at corresponding points, see where the centre of enlargement is, and then I know if I'm going through that centre of enlargement, then it's going to be negative. If I was actually going for a situation where I wasn't going through it, for example, then that would be an enlargement of a positive scale factor, and the further I went away from here, the more that scale factor of enlargement would be positively. But in this case, it's negative. Well, for question 17, the diagram shows Helen's fish tank, and I think on first sight, one common mistake would be to just do the volume of the tank would be 120 times 40 times 70, which would give you 120 times 40 times 70 would give you 336,000 centimetre cubes, and then divide that by 14 and then see whether the answer would be okay. But that's not what this is asking here. I think the trick here is all the dimensions are correct to the nearest centimetre, and here the 14 litres is correct to the nearest litre. So what we can do is we could try and pretend that we were doing it this way. And then what we've got to do is try and find the most amount of buckets that we could possibly get to see whether 25 would be enough. So if we have a fraction a over b and we want the outcome to be the most, then surely we'd want this number here to be the most it can be and this one to be the least. So if you think about it like this, and I always use the idea of cakes and people, if you want to have the most cake, then you want to have more cakes on the table and the least amount of people showing up if the cakes were shared equally. So in this case, you're going to want the upper bounds of all of these and the lower bound of this. So I think we're good to go now, and we should be okay. So let's have a look what we'll have. So we'll have, if we want these to the nearest centimetre, so to the nearest centimetre, I always look at this like a seesaw. If you cut it in half, you can have half a centimetre either way. So in this case, if we want to go the upper bound or the lower bound, then we can look at it accordingly. So in this case, we want to go upper, so we want to add half a centimetre. So we're going to have 120.5 times 40.5 times 70.5. And then in terms of litres, it's correct to the nearest litre, so we take the litre, again split that in half, and we know that we want the upper bound, the lower bound of that, sorry, so we want that to be a half taken off, so we want 13.5. Incidentally, I know a lot of students say, well hold on, 120.5 rounds to 121. Well, you could do 120.49 recurring, but of course a lot of you know that if you do 0.49 recurring, as soon as you round this anywhere, these all become zeros and this becomes a 1, and you end up with 120.5 anyway. So you've got the upper bounds of all the dimensions at the top, and you've got the lower bound of the litres that one bucket will hold. So we can do that on a calculator. So 120.5 times 40.5 times 70.5 gives me 344,057.625 divided by 13.5. That gives me an answer of 25485.75. So let's have a look. Now you might think that's complete rubbish, but one thing you've got to think about here is that 1 litre is 1,000 centimetre cubes. So all you have to adjust here is this. So I made a little mistake, but looking at the answer, I know that I can check this out and see what happens here. So if I'm dividing by another 1,000, then by 10, 100, 1,000, I'll have 25.48575 buckets. So 25 will definitely not be enough. So no, it's not definite. So I made a little error there, but instead of like starting the question again, you may as well see how I would have done it, and I would have just checked my answer because that didn't seem to make any sense, and then I thought, well hold on, 1 litre is 1,000 centimetre cubes worth of volume. Okay, so that one seems a bit tricky, so let's move on. Question 18. It says here that T is inversely proportional to the cube of u. So that means t would be inversely proportional, i.e. 1 over u cubed. So that means that for some value of k, we would have the formula t equals k lots of 1 over u cubed, which can be written like that. You can write it like this if this worries you, so you can write it like that if that's better. What that would mean is when we want to plot this graph, there'll be some graph that will take on exactly these values, and that's why they give you them, because these values enable you to find the missing link, which is the value of k. So I'm not going to go into too much detail on these, because I've done these on previous questions before with probably more detail than what you really needed. So let's just put the values in and see if that helps us find the value of k. So this is a calculator paper, so we're going to be okay with this. So if t is 0.0096, that means that will be equal to k over 5 cubed. So that means k would be 0.0096 times 5 cubed, and we can do that on the calculator. So let's have a look what that gives. 125, that's 5 cubed, times 0.0096. Well, I get here that k is 6/5. You might get 1.2 on your calculator, which is fine also. So we know that this curve is actually 6/5 of 1 over u cubed, or 6 over 5 u cubed, exactly the same. And I could sketch that. I don't think I'm going to put that on right now because I don't think it'll be too relevant to you, but all we now need to do is find the value of u when t is 0.15. Well, in this case, let's create a little bit more space. So we've got t is 6 divided by 5u cubed. We've got to find the value of u when t is 0.15. So just by rearranging this, we would have timesing both sides by 5u cubed would give us this situation, and then dividing both sides by 0.15 would give us this, and then divide both sides by 5 again. I'll do that on my calculator. This is a calculator paper after all. So we'll have u cubed would be 6 divided by, open bracket, 5 times 0.15, close bracket, and that would give me 8. So that means u cubed would equal 8. So u would equal to 2, the cube root of 8. And if you wanted to do that on your calculator, I think you could use this button here and just do cube root. Don't forget to put a little bracket in here. Okay, so 8, the power button, bracket, 1 divided by 3, close bracket, and you'll get the answer 2. Okay. Question 19. By completing the square, we've got to find the coordinates of the turning point of the curve with equation y equals x squared plus 10x plus 18, and that should be okay. So if we complete the square, then we have x plus half this value all the time, this sign always follows, squared. Now if we did x plus 5 times by itself, don't forget we'd get x squared, we'd get 25, we'd get 5x here and 5x here, so that would be our 10x as required. So we've got our x squared and our 10x, but we've got a 25 here, and we never had that up here. Okay, forget this 18, we're just adding it at the end. So because we have a 25 when we times x plus 5 by itself, We didn't have that value here, so we have to take that 25 away. Then this is exactly the same as this. So we then have y is x plus 5 all squared minus 25 plus 18 is minus 7. Now how does that find the turning point of the curve? Well, the curve has a positive coefficient of x squared, i.e. 1, so it's going to have this type of shape. So it's going to have a line of symmetry and a minimum point. Now, if we want to minimise, that means we'd find the minimum value. If the curve had this kind of shape, we'd be maximising it, okay? And the maximum would be up here. So we want to minimise it. So we want to make this as small as possible. And the only way of doing that is to call x negative 5, because negative 5 add 5 would give us 0. 0 squared would be 0, take away 7. So if we said x was negative 5, then y would be negative 7. Now you may ask yourself, well I can put a value even lower than negative 5 in there, and surely that would make it even lower. But if I said x was minus, say, 10, minus 10 add 5 would be negative 5, but here's the catch. Because we're squaring it, it turns positive and makes it a large value, okay, not a negative one. So that would make it 25 minus 7, which would be 18, which would be somewhere else on the graph, but not the minimum value that we require. So to find the minimum value, basically what we always do, and I'll change the colour on this, is we always try and make that bracket 0. Okay, so if you can do that every time, you'll always find the minimum value, i.e. the minimum value that x could be, that will make the y the minimum value also. So I have a few goes at those types of question, but they're generally always the same. Question 20, well that's a circle theorem, and we've got angle ADE is 54, so this angle here is 54 degrees, and we've got ABC is 114, so that's that angle here. We've got to work out the size of angle CAD, so C to A to D, which is this one here. That's what we've got to try and work out. So let's have a little think here. Right. I personally would say angle ADC is 66 degrees, and then that's because opposite angles in a cyclic quad, you can use an abbreviation, I don't think it would hurt too much, add up to 180 degrees, and you could show your workings or not. I think in this case you can just say 66 because you've shown, but if you don't want to do that, you can just do a little calculation here, okay? And then angle CDF, well, that's to do with angles on a straight line, and I've put my explanation here. And then lastly, I would say angle, and you can write that as this sign here, or just write angle. Angle CAD is going to be 60 degrees then. So let's just put this one here as 60, because we wanted to put that one in. And then that's to do with, well, what do you think it's to do with? If you think of your diagram here, the angle between a chord and a tangent is equal to the angle in the alternate segment, because this is one segment here, and this is the minor segment, and this is the major segment. Okay, so again, the angle between a chord and a tangent is equal to the angle which is in the alternate segment. So if you wanted to look at this one, chord, tangent, then this angle here would be 54. But in this case we want this one, so I'm going to put my explanation down here for you. Okay, and so angle CAD is 60 degrees because of the alternate segment theorem. Okay, so that should be quite enough to get you all the marks for that question. Question 21. F and g are functions such that f of x always gives us 3x squared and g of x always gives us the reciprocal of x minus 2, i.e. 1 over x minus 2. We've got to find g f of 4. And my advice is to break this down from the inside to the outside. So always start on the inside here and then work outwards. So if we do f of 4 first, that will be 3 times 4 squared. What I don't want you to do is think that it's 3 times 4 then squared. So to write f of 4, it's probably better just to say 3 times 4 and then have the square outside, then you won't get confused. So that will give us 3 times 16, and you can use your calculator if you needed to, and that's 48. Now we want g of what that value was. So really we want g of 48. So all we do then is just put 48 in here. So we'd have g takes on the value of 48 would be 1 over 48 minus 2, which is 1/46. Question 22. We have an expression here, a plus root 8, and we want to square it. Well, let's see what we'd get. We'd have a squared. Root 8 times root 8 is just 8. Here we'd have a root 8. I wouldn't write root 8a because it might make someone think that you're putting the square root sign around the a as well. So I would put the a in front. So a root 8, and then here we've got a root 8. One thing to say to some people is, if you wrote a2, for example, that would be wrong. But for some reason in maths, if you put a root sign around something, you can write the letter first. Okay, just in case some of you are wondering. So in this case, we'd have a squared plus a root 8 plus another a root 8 plus 8. That gives us a squared plus 2a root 8 plus 8. Now the interesting thing about this question is it wants it in this form. So if we take a squared plus 2a root 8 plus 8, we can put the a squared plus 8 in front, and I would reckon that would be our value of c. Now we're just going to look at this part here, 2a root 8. Well, we know that root 8 is root 4 times root 2, so that is 2 root 2. So 2a root 8 would be 2a times 2 root 2, and 2 times 2 is 4, so that would be 4a root 2. So we want the value of d, so d must be 4a because it's d times root 2. So there we go. C is a squared plus 8 and d is 4a. Question 23. We've got to show that the equation 2x cubed plus 4x equals 3 has a solution between 0 and 1. Now, I would personally rearrange this to get everything on the left-hand side by taking 3 off both sides, and then I would simply look at this expression, 2x cubed plus 4x minus 3, call it y, so we can plot it, and then look at this expression, which is easy, it's just y equals 0, i.e. the x-axis. So if I just put this on as x, and this is y, we can see here that between 0 and 1 the curve does indeed cut the y-axis, the x-axis rather, i.e. 2x cubed plus 4x minus 3 is equal to 0 for some value between 0 and 1. And what we would do here is, if we said our function f of x is 2x cubed plus 4x minus 3, if we put 0 into here, we're just going to get 2 times 0 cubed plus 4 times 0 minus 3, which just gives us minus 3. And if we look carefully on here, minus 1, minus 2, minus 3 is exactly where we'd be. And then if I just write this up here, if we do f of 1, that would be 2 times 1 cubed plus 4 times 1 minus 3, which would give us 2 plus 4 minus 3, which is 6 minus 3, which is 3. And you can see here 1, 2, 3. So this is 3 too much, and this is 3 less. So there's a change of sign. So what I would say is change of sign. Therefore, solution lies between, and I would just put 0 and 1 in an open interval like that. You can just write it in a longer sentence if you want, but the examiner will have a good idea of what you mean. So that's how I would do that first part. Part B, we've got to show that 2x cubed plus 4x equals 3 can be rearranged to give this here. Now, generally what I would do, because this comes up in A-level as well, believe it or not, for Year 13 students, which I know you find that hard to believe, but it does, I always say to them start from the answer and work upwards. And the examiner would never know. So if we times both sides by 4 here, we'd have 4x equals 3 minus 2x cubed, because the 4 here divided by the 2 would give 2. And then I can get the x cubed term onto the left hand side by adding 2x cubed, so I'd have 2x cubed plus 4x, and then I've got my 3 waiting for me here. Okay, so you can do it both ways round, it doesn't really matter. It's not really cheating because you do understand what you're doing. So that's the way to do this one here. So now let's look at the last part. So let's move this stuff up here. It says start with x0 is 0, i.e. our first value of x to be 0. Use the iteration formula 3 times to find an estimate for the solution of this equation. Now, what I'm tempted to do is do an explanation using a graph to show you how this is done. So the idea here is that if we have y equals x as given, the green line here, and in here, the left-hand side, it's always the case with iteration, always want to put x equal to some other function. And then there's the other function here. Now we could have rearranged 2x cubed plus 4x equals 3 into many different ways with x on one side. There's not just one way. But as there's 3 solutions to this cubic, there's probably multiple ways of getting those different solutions. So this will get you one of those solutions, not all the others. So the idea with starting with x0 is 0 is to say, right, okay, my first value of x is 0, so this reads up to the graph, and then along to another value of x that we then try. So if I put x equals 0 into this iterative form, let's see what we'd get. And our graph should tell us the truth on this so we can see. So don't forget, n plus 1 is greater than n, so when n is 0, we'd have x1, i.e. our next value, would be 3/4 minus, well, x0 cubed over 2, so that would give us 3/4 on its own, 0.75. And hopefully you can see that when I put 0 in here, look, this value here is 0.75, 3/4 of the way up. Okay, So what you then do is you then read along back to your left hand side, i.e. your straight line y equals x, which is always there waiting for you. And then this will then look to the graph and there'll be another value. So let's try the next value and see what that gives us. Well, this is a calculator paper, so if n is 1, the next value will be 1 plus 1 will be x2, will be 3/4 minus our previous value, which will be 3/4 all cubed rather, divided by 2. There's many ways of doing this on the calculator. For example, in my previous mock set 1 papers, I believe, I've done an iteration question in a lot more detail, and I do a video with a calculator showing it. So if you just look up the iteration question in the mock set 1 papers, you'll see a video that will help you there. But I'll do this one stage at a time. On the calculator, this would give you 69 over 128, which is 0.5390625. Now, if you think about this, here's halfway, that's 0.5, and if you look very carefully here, this is actually the value that we're looking at here, 0.54 roughly. And so what happens is, and I'll zoom this in a little bit, when you're looking here and you've got your value here, which corresponds to 0.54, this then reads along to the y equals x graph, and then you get your next value, which we can work out. That will then go up to the graph again, which will then read along to the x, and so on. This design is called a cobweb design, or cobweb structure. And all that means is that we're cobwebbing into the actual solution, which we can keep doing more and more and more, and it will become more and more accurate. And it's a process which converges, okay, as opposed to one which diverges, i.e. is not an appropriate form. That was the whole reason behind part A, rearranging this form into a different form. There are multiple different forms you can have. Each will give you a different graph, but you'll always have an x on one of the sides. So let's cut to the chase here and just do the next one. So x3 would be 3/4 minus, well, I'm just going to put 69 128 into my calculator, and that's going to give me a decimal of 0.671677 and so on. So to 3 decimal places, I think it was. Let's have a look. Well, it doesn't say actually, but I will give it to 3 decimal places, which will be accurate enough. So I'm going to write 0.672, and I'm just going to write in there 3dp. So again, if you want more explanation, look at one of my other papers. I'm sure other people have done good videos on iteration as well. So good luck with that question. Question 24. We have a diagram of a triangle, and we're told that the area is 42 centimetre squares. So the best thing to do here, I believe, is to call this length x, and we know the area of a triangle formula, which is a half times the 2 lengths that are making the angle we multiply. So we always choose an angle in between the 2 lengths. So in this case, x times 7, and that's going to be equal to, just get that correct, so we've got x times 7 times sine the angle, so I'll write that out so you can actually see it properly, a half a b sine c, isn't it? That's the formula. So we know that that's equal to 42 centimetre squares. So if we look at this left hand side here, we have x times 7 times sine 70 all over 2. and on the right hand side we just have 42. So we can find x on its own. So x is going to be, well, if we double both sides, that's going to be 84, and if we divide both sides by 7 sine 70, on our calculators you do 84 divided by, and please don't forget this bracket, and make sure your calculator is in degrees. So we should have, let's have a look, so we've got 84 divided by bracket 7 sine 70, checking it's in degrees. If your calculator starts a bracket for you when you do your sine function, then just do another bracket and then another one. So you'll end up with something that looks like this on my calculator. 7 sine, it opens that for you, so you must close it and then close this one here. So brackets to the left always are the same as brackets to the right. Okay, and then you know you've got your answer. Press equals, and my answer here for my value of x is 12.77013327, and I'd always write down my full calculator display there. So it wants us to find the length of AB, and we'll just call that y. So I reckon now what I can use is the cosine rule. Now when I've taught students in the past the cosine rule, I've always pretended it's the Pythagoras. So I pretend that this is my right angle, and if it was, I'd have x squared plus 7 squared would be equal to y squared. But because this angle is 70 and not 90, I've always got this little correcting factor, 2 times x times 7 cos 70, to take away from this x squared plus 7 squared. So that's my left hand side expression, and all I have to do is put the value of x that I've already got here, and I can just put that as ans on my calculator. So I can do ans squared plus 7 squared minus 2 times ans times 7 cos 70, and then because it's y squared I can just put a big root sign around that. You can either do that all in one go, so you can either do this and then put a bracket here, or you could have just done this first and then square rooted it at the very end. So I'm going to do it all in one go. So I'm going to try this. So I've got square root bracket ans squared plus 7 squared minus 2 times ans times 7, and you can write a times again if you want, but I'm just going to put in cos 70. It opens that bracket, so I've got to close it and then press equals, and I get 12.2853. So y is, I'll do that in a different colour, y, let's get this done properly, so y would be 12.28532.883, and it wants it to 3 significant figures, so I would say 12.3 and then just write 3SF. Okay, and we know it's already in centimetres because in the actual question there's a line where you can draw, write your answer, so you can just write that like that. Okay, so a bit of area of a triangle, bit of cosine rule, which is really Pythagoras in essence, but the angle's not 90, it's just a different angle. So that's question 24. Question 25. It says there are some red counters and some white counters in a bag. It says 7 of them are red and the others are white. So we're going to say the white is X. Alfie takes at random a counter from the bag. He does not, so it's without replacement, put the counter back. He then takes at random another counter from the bag. It already tells you that 21/80 is the probability of taking the first one being white, well, the first one being white is x out of the total number of counters, and so then times the second counter being red, which is 7 out of, now we'd have one less counter to choose from, because don't forget he does not put the counters back, so it'll be x plus 7 minus 1, which is just x plus 6. So we've got a nice little equation there, which doesn't look too worrying. So what I think we should do is try and solve that equation. So I'm going to multiply, cross multiply, if you know what that means. I'm just going to times both sides by x plus 7 times x plus 6, and then both sides by 80. So I'll have 21 lots of x plus 7 times x plus 6 equals 80 times 7, you can use your calculator if you need it, 560x. Then multiply, I'm going to use a square bracket here, would have x squared plus 13x plus 42 equals 560x, which would give us 21x squared minus 287x plus 882. So that would be on that side, and I'd have naught on this side here. Now obviously you can do more steps than that, you don't have to do it literally in one step. I think this question's a little difficult because I don't know about you, but I've just noticed that you can times all of these by 7, but I don't know how many people would see that straight away, because if not, factorising it's going to be really difficult. So I reckon a lot of people would have found that hard. So 7's into 21, that's 7 times 3x squared. If you do a little division sum here, you'll get 41. And if you do the same thing here, 7 into 8 is 1 remainder 1, 2 remainder 4, that's 6. So 7 times 126. So you'd end up with, if you divided everything by 7 both sides, then you'd have 3x squared minus 41x plus 126. So I think the best advice I can give you here is, when you've got really large numbers, just try dividing by simple things like 3 or 7, just small numbers, and you might just hit lucky and be able to cancel it down a little bit. Now, if you want to factorise this, I'm sure at this level a lot of you are reasonably comfortable with this. So factors of 126, well, you can have 126 times 1, 63 times 2, 63 is 9 times 7, and if you had 9 and 14, if we did the 3 with the 9, that would give us 27, and we'd only need another 14 more, so the 14 could go in here, and so we'd have to have plus 27x, and then, sorry, we wouldn't, we'd have a minus 27x, and then minus some more to give us a grand total of minus 41. So we'd actually end up with that. So again, quite a difficult factorisation to do, but I've done some playlists on factorisation, and a lot of other people have on YouTube as well, so just type that in and you can get to see how to do that really quickly. So we'd end up with 3x minus 14 times x minus 9 equals 0. So solving this bracket equal to 0 would be 14 thirds, or this one would be 9. Now if it's a number of counters, we're not going to have a partial counter. So we're just going to go with the x is 9 for contextual reasons. So if x is 9, I believe, yeah, that's all we've got to find. So there isn't anything else to do. I thought there was some more there, but there isn't. So we would just write x equals 9, and that is white counters. That's how many there were to start with.